Hi, I'm Tim, and this is video number 10 in the series about anti-gravity matter. In video number 9, I described the galaxy life cycle. In this video, we're going to look into how the Milky Way fits into that story. So this is the galaxy life cycle, and in summary, it starts at the top with an elliptical galaxy, which starts to interact with another galaxy, and then goes through various stages of spiral galaxy before eventually becoming a single merged elliptical galaxy again. So where's the Milky Way in that process? Let me point out that that image on the right is an artist's impression. We don't really know in detail what the Milky Way looks like. But what we observe is that there are molecular clouds between the stars in the disk. The local star density is fairly low. There are several spiral arms. There are many globular clusters that are not in the plane of the galaxy. There may be a galaxy bar. It's a bit difficult to tell from our viewpoint. There isn't much of a central bulge, and there are some globular clusters that are very near the centre of the galaxy. So what does that tell us? Most of the stars in the disk are in the AGM mixed state. We know that because there are molecular clouds between the stars, and because the local star density is fairly low. These are AGM drag spirals. We know that because the stars are in the AGM mixed state and there are more than two spiral arms. There's no big shared AGM boundary because we can see globular clusters near the centre. Globular clusters wouldn't exist within the shared AGM boundary. And that tells us that the Milky Way is at about the 6 o'clock position on the galaxy life cycle diagram. It's round about here. So the Milky Way has been through the process of tidal spirals. The spirals have been broken up and the stars that were in them have been mixed with the anti-gravity matter. And now the galaxy bar is dissipating and AGM drag spirals have formed. However, the fact that there are many globular clusters away from the plane of the galaxy tells us that this process isn't quite as simple as the idealized diagram depicts. Possibly the precursor galaxies weren't elliptical, and maybe there were more than two of them. So what happens next? As time goes by, the dynamic AGM lacuna will lose its flat bottom, and the galaxy bar will disappear. Stars will continue to fall inwards towards the centre. The central bulge will grow and will develop an inner core inside a shared AGM boundary. The stars inside the shared AGM boundary will be in the AGM excluded state. The globular clusters will continue to be eroded away, and the stars that were in them will be left in the AGM mixed state. And after a long time, the Milky Way will eventually become an elliptical galaxy. But how long before that happens? Well, the Sun is 28,000 light years from the centre. It's orbiting the Milky Way, but it's also moving inwards at about 10 kilometres per second. So if we take that as the average, it'll be almost 1 billion years before it arrives at the centre. However, as we move inwards, the central bulge will grow, and it'll probably be only about half that time before the Sun arrives at the outer reaches of the central bulge. Most of the disk will then have fallen into the bulge. Interestingly, that's only about twice the current rotation period of the galaxy. Spiral galaxies really don't last very long. As the Sun moves inwards, the star density will increase. Within the bulge, variations in star speed will also increase. That means that the probability of a cataclysmic interaction with another star will also increase as well. That could lead to disrupted orbits, asteroid showers, planet collisions, or being thrown into the Sun or being thrown out into interstellar space. With that insight, we can see that most of interstellar science fiction is wrong. Science fiction tends to portray the galaxy as a stable, benign environment in which spacefaring alien species can explore and interact with each other. But in reality, it's a transient vortex of destruction. If I was a spacefaring species, I'd be making plans to get out of the galaxy as soon as possible before I got sucked in too far. I might be thinking about hitching a ride behind a small Bok globule as it's blown outwards by the anti-gravity matter wind. And I'll end the video on that happy thought.